Hello, and welcome to this microservice architecture and design pattern series. Microservices are about focus. Each microservice should do one thing well, but operational concerns are unavoidable. Logging, metrics, tracing, security. Embedding these concerns inside the business microservice creates tight coupling and code duplication. In this video, I'll explain the sidecar pattern using a real-world logging example. This is part of Practical Microservices series. Please do check out other videos in this playlist. Every microservice needs logging, but logging is infrastructure concern. When logging logic lives inside the service, business logic gets polluted. Libraries change and standards drift. Upgrading logging requires redeployment. Failures propagate into request paths. This violates a core microservice principle. Operational concerns should be isolated. So we need a better model. The sidecar pattern introduces a companion component. It runs next to the business microservice, not inside it. Maybe within the same environment, same life cycle, but different responsibility. The service remains unaware. The sidecar handles cross-cutting concerns. This preserves the service autonomy. Our use case is logging. The service writes logs locally, structured, simple, and fast. A sidecar runs in the background. It reads logs incrementally, batches them, and sends them to a central logging service. This service does not manage retries. The service does not handle failures. That responsibility should be externalized. This pattern scales naturally. Each service gets its own sidecar. No centralized bottleneck. Failures are localized and behavior is consistent. The sidecar can evolve independently and the business service remains stable. This is loose coupling done correctly. Having said this, sidecars add complexity. More processes, more resource usage. They are not suitable for trivial tasks. Use them deliberately. They shine for cross-cutting infrastructure concerns. The sidecar pattern allows services to remain focused and clean. Our logging example shows how powerful this approach can be. In the next part of the video, we will implement sidecar pattern using ASP.NET Web APIs and C# language. I already have a blank solution created in Visual Studio called Sidecar. Let's add an ASP.NET Web API project to it and call it Central Logging Service. We don't need HTTPS for now. Let's create the project. This API will expose an endpoint so that consumer microservices can send logs periodically to this central location. In real-world application or production environment, this could be an enterprise-grade service such as New Relic. Let's define a variable to store the log file name. Let's add an endpoint to this service called as log. This will save the incoming request body to a local file. In real-world application, this could be a database such as Elasticsearch. This endpoint will read the HTTP request body as a stream, will store the body in a variable, and then write it as a string to the above defined file. Let's add a class library project called Logger Sidecar. This can be consumed as a NuGet by other microservices. This library will contain classes to hold the logs and periodically send the logs to the central logging service. Let's add an interface called iCustomLogger to this project. This interface will have methods such as info, error, and warn so that the consuming microservices can send the info, error, or warning related messages. We will add few supporting types such as log level enum to indicate whether it is an info or error or warning. A log message record type which will represent an entry into the log database. It will store a timestamp along with name of the service, the log level, and the actual log message. A local log message store which holds the log messages in a concurrent queue. Let's implement the iCustom logger interface. We'll inject message store as a dependency. We'll implement the error, info, and warning methods. We'll default the date time to current system date time. Let's move the types to their respective files. Now we need a mechanism to periodically collect the logs from the concurrent queue. A background service would be a good choice for this. This will be the sidecar along with the business microservice. We'll inject HTTP client factory into this class, and we'll also inject the local log message store in the constructor. We'll implement the execute async method of the background service class. Now, until cancellation is requested, we'll periodically check if there are any logs. If there are any logs, we'll read those logs, dequeue the logs from the queue, and send it to the central logging service. We'll check those logs every 10 seconds to avoid tight loops. Let's bring the required namespaces. So the background service is defined in Microsoft Extensions Hosting Abstractions NuGet package. Let's find and install the latest version. Similarly, the iHTTP client factory is defined in Microsoft Extensions HTTP NuGet package. Let's install that as well. Let's move the type to its own class file. Let's install Newtonsoft JSON library so that we have easy way to serialize and deserialize objects. Let's add a couple of business microservices to this solution. Let's call this services as service A and service B. For this demo app, we'll use ASP.NET Web APIs. We don't need HTTPS for now. In service A, let's add the required services. We would need a HTTP client to make API calls to the central logging service. We'll add the implementation of iCustom logger. We'll also add log message store as a singleton. Let's also add the log aggregation sidecar service as a hosted service. We'll define JSON options for easier debugging and logging. Let's add an endpoint called update. We'll inject the iCustom logger into this endpoint. We'll read the request body. We'll call the custom logger info method and send the request body to the logging service. Let's add project references so that the custom logger and custom logger are recognized. Similarly, in service B, let's also add the required services. Now the log message store has to be singleton because we want to use the same log message store for different requests. Let's register the log aggregation service as a hosted service. We'll also add an endpoint called as create. We'll also inject the custom logger into this endpoint. Similar to service A, we will read the request body and we'll send it as a error message to the custom logger. Now let's bring in the required namespaces and add the project references. Let's jump to the demo. Let's open all three projects into terminal window and run the services. I've opened all three projects in terminal window. Let's run the central logging service, service A and service B using .NET Run. Let's send some HTTP requests to service A and service B. We'll send hello info from service A and hello error from service B. These messages should be logged as info and error message in the central logging service in a log file. Let's open the log file generated under central logging service. As we can see, we got a message hello info from service A and hello error from service B. This is how we can implement sidecar pattern in microservices. We get clear separation of concerns, reusable infrastructure logic, and independent deployments. We also get improved reliability and cleaner code base. Operational features stop leaking into business logic. If you find this video useful, please give a like, comment, and subscribe to my YouTube channel. Please check out other videos in this microservice architecture and design pattern series. Thank you for watching.